Alright, so let's go ahead and do the even problems for 12-1 for pre-calculus, and we'll be working 9 through 66 every third. So first one we'll look at here is 12, and so we want to complete this table and see what our values are approaching as the x values approach 0. So remember, the f of x is the same as saying y, so what happens to our y values as our x values get closer to 0, either from the negative side or as we approach getting smaller from the positive side. So in this chapter, a lot of what we're going to be doing is in the calculator. So let me switch over to the calculator, and I've already plugged in the equation here, tangent of x divided by 2x, and make sure the 2x is in parentheses there, otherwise order of operations will be wrong. And I'm going to go to the table set first to set what we want. We're going to start at negative 0.1, and we're going to start counting by hundredths, 0.01 to count up. Alright, let's go ahead and jump to the table and see what we've got. And there's our first value. Negative 0.1 is 0.50167. So let's plug that in. 0.501, it was 67. And we'll scroll down here to negative 0.01, so that's 0.50002. And we're going to have to change our values to get the 0.001, but we can get the positive sides here. Notice there that we hit 0, we get an error. Why would that be? If we plug in 0 here in the denominator, what's 2 times 0? You get 0 in the denominator. Can't happen. So we're going to have an error here. So again, in this chapter, we don't really care what happens at 0. We just don't care what happens as we get closer to 0 from either side. So let's go ahead and look at the positive numbers. Positive 0.01, we've got 0.5002 again. And so this looks pretty symmetrical. Let's go ahead and check positive 0.1. And it is the same, 0.50167. And let's change our table values now so we can see 0.001. So to do that, we'll jump in here to our table set again. And now we'll start from negative 0.01. And let's start counting by 0.001s. And in fact, actually, since we don't need to approach it, we can go straight to it. 0.001. Let's start at that. Just so we can go straight to that value. Check the table, see what it gives us, and it says 0.5. On the opposite side, also 0.5. And so you can see what's happening here. As we approach 0 in the x's, as we get closer and closer to 0 in the x's, our y values are getting closer and closer. 0.50167, 0.5002, just 0.5. So that's what we're approaching. So our limit here, as we approach 0, is going to be 0.5. Let's go on to the next problem, 18. And so on this one, we'll also create a table of values as we approach 2. And the reason I know it's approaching 2 is this part down here. So we want to approach 2 from the left and the right. So let's go back to our graphing calculator, and we'll go into the y equals here. And let's be careful with our parentheses. So clear this out. Parentheses. 1 divided by new parentheses, x plus 2. Close my parentheses. Actually, do I need an extra one? Yep. Let me back all the way up. I'll need 2 to begin here. 1 divided by x plus 2 minus 1/4, and then that whole thing divided by, and then in parentheses, x minus 2. So we're being really careful with our parentheses all the way through. Let's go into our table set, and we want this to approach 2. So I'm going to start with a number above 2, let's say 3. And let's actually start from the other end. I'm going to start with 1 so we can count up. And I'm going to count by point ones. So we'll start at 1, approach 2 from the negative direction. Let's take a look at what the table looks like. Alright, we start with negative 0.0833 as we approach, and we're getting closer to 2. Oh, we get an error. And let's see what happens here. So from the left, 0.061, from the right, 0.0641. What do you think it's approaching here? Looks like it's approaching 0.06. Let's zoom in a little bit more on our table. So I'm going to go back to the table set and start from 1.9. And now let's approach by 0.01s. Really zoom in there and see what we get. Okay, so as we're getting closer and closer, 0.0627. From the other side, negative 0.0623. Okay, and so at this point, we're getting really close. We're not getting the same value, but we're going to see that it is approaching something. It's getting bigger as we go up this way. 0.62, 0.622, 0.623. On this side, it's getting smaller. 31, 30, 28, 27. So we're going to take the average between 23 and 27 here and say negative 0.0625. Alright, so we would need a table to represent that, and so you could copy down the table that we did on our graphing calculator here, and probably just 3 values from either side is enough, from 1.96 down to 2.023 would be enough. Okay, so copy that down and you would have your answer for the table. And then it also says we want to do this and confirm it graphically right here. Okay, confirm your results graphically. So let's take a look at what this graph looks like. And so right now we're really zoomed too far out for this to do much good for us. We want to be zoomed in on an x value of 2. So let's change our window value. Our x values, let's go a little bit less than 2, say 1, and a little bit more than 2, 3. And I'm not going to worry about the y's for right now. We'll do that. We'll let the calculator zoom for us in a second. So I'm going to hit graph. Let it graph. You can see it's still working. Now it's done. I'm going to hit zoom. And I'm going to go to the zoom fit. And that's going to take care of my y values, the up and the down. Alright? It's got a nice curve for us. Let's hit the trace button. And here we go. We can move left and right on our graph. And as we get closer and closer to 2, oh, y disappears because there's going to be a hole there. We can't have 2 in our denominator. But as we approach from either side, 0.0621, 0.0628, so it looks like our answer is absolutely correct. Alright, so we've converted it 2 ways, one with the table and one with the graph. Let's keep moving here to 24. Alright, 24 we're going to do the exact same thing, but as we approach 0 for this. So 1 minus e to the negative 4x all over x. Let's go ahead and punch it into our y equals. Clear this out. Parentheses 1 minus e, and where's e on this? There it is. To the negative 4x. Close that parentheses, close the second parentheses, all divided by x. Only one term, so I don't need a parentheses there. Let me change my table. And we're going to approach 0 here. So I'm going to start from, let's go with negative 0.1 and count by 0.01s. We'll start by zooming in awfully close, just see what happens. So as we approach 0, 4.9, 4.8, 4.7, 4.2, 4.1, 4.0, error. And on the other side, 3.6, 3.7, 3.8, 3.9, error. What do we think we're approaching? If you said 4, that's what we're looking for. So the limit here is going to be 4 based on this table. Let's go ahead and do the graph as well. Remember, we're approaching 0 in the x, so let's change our window to go a little bit below 0 to a little bit above 0, negative 1 to 1. We won't worry about y's for a second, so we can do the zoom fit. Let it stop thinking. There you go. We'll hit the zoom, go down to 0, zoom fit, and it'll reset, and let's see what happens. As we approach 0, let's find out what this y value is. Hit trace. If x is 0, we don't have a y value. but what happens on either side of it? Y is almost 4. On the other side, it's a little bit less than 4. So yes, that is going to be our answer. If we really wanted to get in there close, we could always do a box zoom and really get in there. A little bit to the left, a little bit up, hit enter to start my box. I'm going to scroll down, scroll over, and really zoom in on that spot. Now when we trace, you can really see 3.93, 3.94, 3.96, 3.98, 3.99, and we go to the other side, 4.01. We skip 4 because we skip x equals 0 here. Just the way that the intervals work didn't get us right to it. But you can see that we're getting very, very close to 4. All right, let's keep moving to 30. This one's an easy one. They'd give us the graph, and they say, okay, what happens as we approach 2? Well, here's 2. Let me do a vertical line. This is the x equals 2 line right here. So right here you can see that at x equals 2, we don't have a value. There's a hole there. But what's happening as our line gets closer to 2 from the left and from the right? It's getting closer and closer to this value here. Okay, so even though at 2 there's a hole and there is no value, as we get closer and closer to 2 from the left and the right, we're getting closer and closer to 12. So that's it. That's your answer on 30. All right, 36, same thing. We're going to use the graph as we approach -1. What's happening to our y values? So as we approach -1 from the left and the right, what happens to our y values? Well, we're zooming in here. Let me use a different color. We're zooming in like this. We're zooming in like this. Where do we land? We land right here. And so the value is going to be -1. Just what happens to our y value as our x value gets closer to -1. All right, 42. We're going to use the graphing calculator to see if this exists. And if it does, tell us what the limit is. So let's go back to our handy graphing calculator. Y equals, clear this off. And for 42, the equation is, in parentheses, square root x plus 5 and then minus 4. Oops, didn't need this. Minus 4, and then we close our parentheses so we can divide the whole thing by, in parentheses, x minus 2. Okay, being careful with our parentheses. And I was not. It lost it up there. Sorry. One more time. Parentheses. Square root x plus 5. Close parentheses. Minus 4. Close parentheses. Divided by x minus 2. Alright, and so we want to see this as it approaches 2. And so let's go to our table, and we're going to start at 1.9. And let's see what happens in our table here as we approach 2. So 27, 34, 45, 67, 135, error at 2, and then negative 135. That's interesting. So we've got positive values on this side, we've got negative over here. Let's go to the graph and see what's happening. I'm going to take my window and we're going to go from 1 to 3. And graph this and trace it. Let's see what's happening here. As we approach 2, I'm going to zoom this out a little bit. There we go. Aha! So as we approach 2, this is 2 here, from the left, we're going to positive infinity, going up forever. From the right, coming from the positive direction, we're going to negative infinity. We're going to opposite directions, so this does not have a limit. No limit, because as we approach from the left and from the right, we get different values. Okay? So no limit for 42. Now we go to 48. All right, let's use some properties here of our limits for a, b, and c. Let's find first the limit as x approaches 2. grab f of x and throw in 2 for our x. So 2 over 3 minus 2. We'll get 2 over 1, and so we'll just get 2. That one works just fine. Let's try g as we approach 2. In this one, we're going to have the sine of pi times 2. The sine of 2 pi is going to be what? Do we remember? Remember 2 pi is over here, the same as 0 degrees. What's the y value over there? 0. Okay, so the sine of 2 pi is 0. That works. We can do that one. How about c? The limit of f of x, g of x, as x approaches 2. Alright, so this is really the crux of this problem. Since we already know that the limit of f of x as x approaches 2 is 2, and g of x is 0, we're just going to be able to multiply these together and say 2 times 0, which is 0. Alright? And same thing for the last one. Since we've already done the limit of them individually, we can just subtract them. We've got 0 minus 2. And so for problem D, the answer is going to be negative 2. Alright, so you can combine limits if you know each individual limit. Our last section is direct substitution, and this is the easiest part of all. All you need to do is plug in the values if they work. Okay, so you can do direct substitution for every number in this problem except for x equals negative 2. Because if you plug negative 2 in there, you'd have 0 in the denominator, nothing would work. But negative 5 is just fine. Let's plug it in. 6 over negative 5 plus 2 is 6 over negative 3, which is negative 2. That's your answer. Just that quick and painless. Like those. Same thing for 60. 3 works just fine in there. We're going to plug 3 in for x. We're going to square it. 3 squared is 9. 9 minus 1 is 8. And this is the cube root. Cube root of 8 is positive 2. 2 times 2 times 2. And that's it. All right, last one, 66. Direct substitution, let's see if this works. We're going to plug in pi for x. Is the tangent of pi a legitimate number on this one? And let's go back to our unit circle here. Pi, remember, is over here. And the value there, that's negative 1 comma 0. Remember that tangent, think way back, is y over x. 0 divided by negative 1. Is that a valid answer? Yes, it is. So we get 0. And that is our answer. Okay, so direct substitution, if the number that x is approaching works, you can just plug it in. If not, you're going to have to go to the table or the graph and see what happens as we approach that number. All right, and that's our Introduction to Limits 12.1.